Welcome back to the OSM channel. Don't you just love it when what seems like is going to be a half-hour project turns into an all-day affair and a bit of a nightmare? Well, that's exactly what I'm facing today. Now, this is a frost-proof wall hydrant, and it's in my garage, and I rely heavily on this hydrant in the wintertime. One, to wash out the cars, but two, I also use this to wash and clean my maple syrup making equipment. So this is a critical piece of infrastructure within the house here. Now, this past winter, it started leaking at the vacuum breaker on top of the valve, and it also started leaking at the valve stem. So I thought to myself, I need to repair this wall hydrant before this winter. Well, I went online, started doing some research. I thought this was made by Prier. I thought this was a model 400 or 500 series wall hydrant, so I bought the repair kit. Turns out this is not made by Prier, this is made by Nibco. So I called Prier, they directed me to Nibco. On the Nibco technical assistance line, the technician said, "Oh, sorry, we stopped manufacturing repair components for that valve in about 2007. Well, I asked the guy, can I get aftermarket parts? He said, maybe the vacuum breaker, but the internal seals for the valve stem, no, there's nothing you can do. You'll just have to buy a new one. Which is frustrating because these valves, these wall hydrants are supposed to be repairable and nobody makes parts. So I'm left with the decision, do I leave it leaky, which is not an option, or do I replace it? And being the person that I am, I'm going to replace it. Now, normally, you can access the wall hydrant connection on the inside of the wall, you know, in your crawl space or your basement. However, this one's a little bit challenging to access because there is about a 2-foot protrusion into the garage space. And in order to get to the connection where this valve connects to, you know, the supply line coming out into the garage, I'm going to have to cut a hole either here or underneath this protrusion coming out of the wall to access that connection. Now I'm hoping I find a threaded connection and I can remove this hydrant by spinning it off. But if I can't spin it off that connection, well then I'm going to have to sweat on a new one. And I've only sweat pipes one other time in my life, so this will be a learning experience for me for sure. But regardless, it has to get done, so let's get moving.
Well, it looks like we have a soldered connection between the copper and the hydrant. It looks like this is probably 1/2 inch. I have a narrow pipe cutter, but it's only designed for 3/4. So for now, we're just going to take the oscillating tool. We're going to cut the copper pipe here. And then when we come back in, we'll do a nice clean cut. We'll deburr the inside of the pipe. I think I'm going to have to get some tools, but let's just get this out of here for now.
So here's the isolation valve. To the left of this valve, it goes directly to that wall hydrant, so we'll shut this off. Hopefully.
I gotta pull these 2 screws. Here's your problem.
So I just got back from Lowe's, spent a little over $100. I think the new frost-proof hydrant alone was around $45, but while I was there, I also invested in some tools that I really needed to complete this job. And I felt like it was a smart investment buying some new tools to allow me to repair copper pipes, sweat pipes in the future. So I had a few things already. I already had a MAP gas torch, which that'll work. I already had a soldering kit. But I needed a low profile pipe cutter, which you saw me earlier take the oscillating tool and I cut the old hydrant out of there, which is not ideal. Ideally, you know, when you're getting ready to sweat on a new connection onto a copper pipe, you want to use a pipe cutter. So I didn't have a low profile one that would work with that 1/2 inch. This one will work from 1/8 inch to 7/8, so that was a no-brainer. I also got a deburring tool because after we make a nice clean circular cut on that pipe, there's going to be a little burr on the inside of that pipe, and we need to remove that burr to ensure we don't have any flow issues, or I think it's called cavitation. So we just want to ensure that we're having really good flow through that pipe. I also got a 4-in-1 brush. So this is really important, for one, to clean the inside of the new brass fitting that I am going to sweat onto the existing piece of copper, because otherwise you don't really have a good way to clean the surface. It's really important that we get these surfaces clean. But also you can clean the exterior of pipes if you have room to work with, which I really don't have room to work with that existing piece of 1/2 inch up underneath that subfloor. So I also bought some sand cloth, and this is what we will use to clean and sand the existing piece of copper. Now I got some stainless steel screws. You'll see why here momentarily. But I also just want to mention that the old frost-proof hydrant, I believe, was 8-inch. And I guess that's the length of the stem. And the new one I got is a 10-inch. And the reason I got a 10-inch was because obviously when I cut that piece of copper, I shortened up the run just a little bit. So by getting a 10-inch, this allows me to sweat the existing copper pipe directly on here without having to use any couplers and pipe extensions, so I felt like that was just a smart move. So one thing I absolutely hated about the pre-existing hydrant was that there was no backsplash. This was fastened directly onto the drywall, which is just a terrible idea, because if you disconnect the hose with a little bit of pressure, obviously it's going to spray back onto the drywall, and then you're going to have issues with your drywall. And I think you guys saw that they put this hydrant right on a joint, and the joint tape is obviously failing. So what I decided to do was manufacture my own splash guard. Now, I was originally going to use a piece of stainless steel. I was looking around at Lowe's, but the pieces of stainless, very expensive. I'd have to spend $60 to $100 to get a decent piece of stainless. I was going to use aluminum, but it was too flimsy. So what I ended up doing, I had a piece of 1/8 inch plate laying around. I decided to cut it to the size I needed, drilled a hole for the new hydrant to be received into, pre-drilled the mounting holes for the 2 fasteners that are going to go on either side of the flange for the hydrant, and we're just going to fasten this right onto the wall. Now, how I got this finish, which it actually kind of looks like stainless steel, does it not? Well, I've used this trick many times in the past, and what I do is I take my angle grinder with a flap disc. This is what I used. I used a 60 grit flap disc, and I just went in one direction. It kind of looks like polished aluminum as well. So flap disc, go in one direction, remove all the rust, try and get all that mill scale off there. And here's what you do. Get yourself some Rust-Oleum crystal clear enamel, and I sprayed a few coats onto this plate, and now we have a water resistant coating on this splash plate, which again, this is going to be in the garage. It's really not going to see much water get splashed right on it, but when water does splash onto this plate, it's not going to rust or corrode the metal, and we have a nice, beautiful finish. So really pleased with how this came out. Now, before I sweat this hydrant on, it's really important that we remove the internal guts, right? Because there's a stem in here, and those really precious seals are right about here. So once we start applying heat to the end of this to sweat it onto that 1/2 inch copper, if we don't remove that stem, we would burn up all those seals, and then we need a rebuild kit, which we don't want that. So let's go ahead and remove the stem, which we're going to start by removing the fastener on the end of the handle here. Pull the handle off. So looking at this packing nut, I'm noticing that there are machine marks opposing one another on this nut, which indicates this is a left-handed thread packing nut. So in order to loosen and remove this packing nut, we actually have to twist this to the right. In this case, this is righty-loosey, lefty-tighty. So we'll pull this out. There should also be a packing washer in here, which we'll see if that stays in place. So now I'm going to put the handle back onto the stem, and I'm going to rotate counterclockwise a few turns, and we'll try and pull this out of here. And we can see, I believe this is graphite, right? That's our graphite packing, and we'll pull this out very gently. Now the seat seal on the end of the stem is fighting me a little bit when I try and pull it past the hose bib connection. So I've decided to just leave it where it is. You know, those sensitive seals are now pretty much at the valve. So in order for those to burn up, the heat would have to travel a full, 10, 12 inches here. So I think that's going to be fine. If anything, I'll put a damp rag over the valve just as an added layer of protection, but we shouldn't have any issues being this far away now. All right, finally time for stage 1 of reassembly. So I'm going to insert this hydrant through my splash plate. Carefully feed this into the hole in the wall. We'll have to fasten this plate to the wall. An important thing about these frost-proof hydrants, they must be pitched downwards if possible. And that's crucial because if we want to ensure that water escapes from this area, if it's not pitched down, then how's water going to flow out, right? So I'm pushing on the valve from the outside, and we need to make a mark as to where we're going to cut the existing pipe, which the stop should be right about here, just a little bit back from the end of the threads. So we'll make our mark right there, and that's where we need to cut the existing copper. So slide that out of the way a little bit, and then I need to get my low profile pipe cutter. So we'll line the blade up on our mark. We'll rotate this. Not sure if it matters which way we rotate it. Just want to keep it straight or perpendicular to the pipe. It's looking pretty good. Tighten it up a little bit. There we are. So we need to deburr the inside of this pipe. I have my deburring tool. It'd be nice if I could get a second hand on this pipe. That should be good. Next we'll clean this up. So we're going to have to sand this down. Looks nice and clean. Now we need to prep the end of the hose bib. We'll take our 1/2 inch 4-in-1 brush. Just brush out the inside. Alright, let's make a mark where this should bottom out, which is around there. Apply my flux. Looks good. And the final thing we had to do before we sweat this is I actually had to put the fasteners into the bib. Well, I think we're about ready. I pulled the valve stem out as far as I felt comfortable. I do have a wet rag sitting on top of the rest of the valve. I have a bottle of water nearby. I have a fire extinguisher nearby in case we light something on fire. I did install some temporary flashing just as a heat shield because catching everything on fire is definitely a concern of mine, being somebody that doesn't do this regularly. I think we've crossed all our T's and dotted all our I's. The 1/2 inch is firmly seated. Everything's clean. Just got to grow a set and do it. So I think I'll apply the heat this side. So we'll kind of focus here, here, I'm going to try and draw the solder from the other side, and when that starts to draw, then I'll come back around. Wish me luck. Oh, that solder is hot. I think I got safety glasses on. I think that should do her. Yeah, that looks pretty darn nice for a first timer. Okay, I'm gonna let that sit for a second, and then from my understanding you want to wipe the flux off. Maybe I put a little too much flux on there. Yeah, that heat shield worked out real nice. Beautiful. Okay, we'll let that cool for maybe 5-10 minutes, reassemble the valve, and give it a test. It's been about 10 minutes. Things should be nice and cool now, so let's go ahead and attempt to reassemble this valve. We're going to push this in. We gotta rotate it to the right. Put the handle back on. We'll twist the stem back in. Okay, that stem feels nice and tight. Next we need to reinstall our packing nut, which the graphite packing washer is in fact still on the stem. Again, because we have these machined indentations on either side of the packing nut, this is a left-handed thread packing nut. So lefty tighty? Yeah, lefty tighty. Shouldn't take much. Snug her up. Leave it there. Put our handle back on. 3/8 fastener. Feels pretty good. One thing to do now, we gotta turn the water on and test for leaks. Let's turn our service valve back on. Let's go out in the garage and see if we have any leaks. No leaks. Let's test out the valve, ensure it's functioning properly. And again, because this is a frost-proof hydrant, it's normal for this to drip for, maybe up to a minute after we shut this off, because it has to allow for that water to evacuate along, in this case, the 10-inch shaft. So we'll just watch this for a moment, ensure that the drip stops, but so far so good, looks good. And after about a minute, the water has stopped dripping, indicating that all the seals are good. This is a good repair. I'm actually going to leave the cavity on the underside of this valve open for tonight. I'm just going to peek in here every half hour just to ensure that we don't have any kind of fire or anything like that, because I'm just so paranoid about fires when it comes to sweating joints. Which I think that's one of the reasons why so many guys have moved from sweating pipes to the Pro Press. Now the Pro Press, you have these clamp-on fittings, you just clamp them, you don't have to worry about setting the house on fire. It's a lot quicker, but personally, in terms of longevity, I think nothing beats a sweat joint. Anyway, I'd like to thank you for watching as always. I will catch you on the next one.